Okay, welcome to this workshop in which we will see how to work with data analytics, integrating Node-RED with the Snap4City API, the so-called SCAPI. In this workshop we will see two examples in two different programming languages, which are R and Python. The first example is about data retrieval from a public sensor, and the other is about the data retrieval from a private device inside the Snap4City platform, both in a specific window of time with the goal of obtaining some simple statistics that are the minimum, the mean and the maximum of the sensor values in the specific window of time. But how can you select a device inside the Snap4City platform? Inside the Snap4City platform there are a lot of devices in which you can choose the one that you want to retrieve the data. There is this useful online user interface, the service map, that allows you to select your sensor, your device, with a map. So you have the map, for example, located in Florence, and you search the type of sensors that you want, for example road sensor. Then what do you need to identify the device? You should search about the service URI. The service URI is the so-called link that identifies the resource. For this workshop we have two sensors, a public one that is a traffic sensor identified by this sensor URI, that is the Metro 762. The sensor URI is this complete link, and the other one is a private device accessible through an authentication procedure that we will see later in the detail, and the service URI is this one. In particular, this is a plastic waste container located in Amsterdam, whose weights are collected and sent to the Snap4City platform. So, but what are the SCAPI? The SCAPI are the Snap4City API that are the tools that you can use to get different data, different information that are stored in the platform. We have the documentation available at this link that is pretty intuitable. However, under services there is the tool that we need for this workshop. We want to retrieve data from a specific device that we saw it is identified by this service URI, and also we want to specify the temporal window from which we want the data to start to which time the data we want to end. For example, today it is the 3 of July, so we want to retrieve, for example, the data from the 1st of July up to now, that is the 3rd of July. So, for example, regarding the public traffic sensors, below here I have reported the GET request, the request for the data. As you can see, there is a link, there is specified the service URI with this link, Metro 762, and also the from time parameter and to time parameter. Let's try it. Yes, we have a lot of so what I did, I clicked here, that opened a new window. I will refresh it. So we have this type of data. This is a feature correction, there are a lot of information, but what we are interested are the, let's see, vehicle flow values of this sensor. If you go down, you will see in results bindings the measured time and also the vehicle flow value. Okay, next, what do we have? How to retrieve the data from private devices. So of course, if a device is private, you need some form of authentication procedure to get the data. So you will need to have the so-called the access token. But how do you get the access token and what it is? To get this access token, that is the keys to access the data from this private device, you will need to do a post request in which you specify the username and password of the owner of the resource or other accounts that have the grants delegated to access this resource. It is more or less the same procedure. We have the URL, the URL, in which we can ask for tokens. Here we pass the username and password, and what we get? We get this type of data. So the access token, that is a long string in which there are encoded some critical information. This is the type of this type of token, and how many seconds we have left before it expires. And so you need to do another request and so on. Before this one, I wanted to mention this. For example, this is the icon that represents our request. This is the type of information that we want, and we encapsulate this in this request. Next, we send this request as we saw earlier, and we get the data about the traffic sensor. The difference between the first one and the second one is only that together with this pink information that has the get request with the service URI, the from time and to time, we append also this access token to the request. So now, with the grant of accessing this data, we make the request, we get the data, this time about the waste container. Hands-on section. So for example, we want to compute the minimum, the min and the max. About what? About the traffic data from time from this time to this time. So from July 2021 01 to the 13th of the same year, with this hour, minutes and seconds. But these are only variable names, so you can also call it a start date and end date. The important part is that when you make the request, let's go back here, you specify from time and the data to time and the data. So this when you create the request, here you will have from the 2021 January up to the 2022 of March. We want to get the weights collected about this waste container. Let's go into the Snap4City platform now and see Node-RED. As you probably have seen in this Snap4City course, you will have under Processing Logics IoT app the section about the IoT applications. This is an IoT app that I created for this workshop. And so which are the main components? We have a first part that is the first example with the R language code regarding the traffic sensors. We want to retrieve the data and compute these min-max statistics. What do we have? We have an inject block, a debug block and a function block in which we will specify the parameter to the code. Let's see what we have here in the function. We have the to time, the from time and the sensor URI. Do you recognize these parameters? Metro 762. We have 1st of July, 13th of July of the 2021 year, that are this one, right? So In this first example we want to retrieve the traffic data. Let's test if this works quickly. We have to deploy, and then we want to see. Okay, wait for a moment. Okay, it was hidden. I have found it. So if I inject this message, I will retrieve from time to time and the sensor URI here about the Metro 762. Perfect. What do we want to put here? To compute those statistics, I have prepared a bit of code in the R language that we will see now. I should have here prepared. We have this R script, and we will open with the text editor. Here I have defined a function called the summary matrix, which gets in input the sensor URI, the from time and the to time parameters. Here I install a library if it is not installed, and then I compose the API with the base URL specifying the sensor URI, from time and to time parameters. So now from time you see, and to time parameter. I get this information from the values passed here. What goes under in the backend is that this code is plumberized at this endpoint. This is an important line of code. However, it is commented, but it is used. So you can see summary matrix the same as this one, and this information will be key to know the read. Next, we use also a try catch to display eventual error in the computation of this resource. We get the results in the JSON, that is a standard encoding, and we should select the array of vehicle flow data. We investigate this JSON, real-time results bindings, and vehicle flow value. Next, we use this summary function in R that allow us to get some basic statistics as the minimum, min, and maximum. Next, we create the string and we encode in JSON this string, and we return the results. Let's try to put the script using the Plumber Data Analytics in Node-RED. Now we will search for data, Plumber Data Analytics. Perfect. We will open it, and next we will specify here the name of the function that, of course, I forgot. Sorry. I will go back and copy this. Summary matrix I hold, not a so explainable name, but we can specify another name here. For example, R statistics, traffic statistics. We will now upload this R script, and we will create this Plumber Data Analytic. Perfect. Successfully created, sending a JSON in input with the parameters needed by the R script. And as you can see, to time from time sensor URI are the one that we want here. So, done, deploy. Oh, sorry, I didn't connect it to the function and the debug. Deploy it. I will delete this log, and I will inject. What do we get? We get exactly the results that we want. That is minimum of 12 cars per hour. The traffic flow measures the traffic per hour. The mean value in the period of time that we selected is 1017 cars per hour. The Metro 762 is in one of the most trafficated routes in Florence, and then we have the maximum. Perfect. This is simple because this is not a private device, so anyone can access this type of data. Now the situation gets a bit more complicated, as we saw, because we need to append to the request also the access token. let's see now this Python code. So after we saw the R code to get the data about the traffic sensor, that is public device, now we will see the case that is a little bit more complicated about how to access the private data about this waste container with this device in which we have the authentication to get the data. I have a timestamp, and now we have also this time a function. In this function, as you can see, I have a lot of some more parameters. Start date, the first the January 2021, and date March 2022. The sensor URI, that is the one that we saw in the slides about the plastic container in Amsterdam, of which I have a user and a password that has the grants to access this type of data. Probably in post-production I will have to blur this part because not everybody can access this type of data. So as we saw for the R script, I will open the Python script. I will open with a notepad. Perfect. Differently from the R case, now we don't have plumber, but we have Flask. And as for the R case, we have a function, and I don't have any more that commented line, but I have app.route and then /script value. This is key importance, because if these don't match, and also the node part won't match, this will not work. So we have the name of the function, we specify / the name of the function. I can do it right now. I will get this Python data analytic, because I can forgot this type of information. I will put it here, script bello, and now I will put here a more meaningful name for what do we want to do. So waste statistics, plastic waste statistics. Perfect. I will upload later. Now let's comment a bit about the structure of this Python script. Differently from Plumber, now we don't get the parameters through the name of the function, but we have to do this type of code. Here you can with the string flask.request.values.get the name of the parameters. As you saw earlier, these are the parameters specified in the function before the other block, sorry. So this is the section in which we get the data from Node-RED, and now we go into the program section. First, as we saw in the slides, we need to get the token. So we make this post request with the URL for the token, and we give also our username and password. These are the name of the functions in which I got the user name. Next, once we make this post request, we access this access token that we can use in our header for the request. So we compose our new URL, the pink one, with the base URL and the specified sensor URI, the from time parameter with the start date variable, the to time parameter with the end date variable that are here, and the access token. So we compose our request.get with URL and the new header with also the authentication token, access token. If the response goes well with the code 200, I will JSON load the result and navigate through this result to obtain the weights. So here we get the weights of the waste container that are encoded in this standard JSON format. How do I compute? This is a vector that represents all the waste collected the weights of this container in the period selected. How I get the minimum, the min and the maximum? In Python you can use this one, min, max, and here I hard encoded the mathematical way to formulate the mean value. Then I JSON encode the response and I return. So let's test if this Python script works. I will upload it now and I create Python data analytic. Perfect, successfully created, sending a JSON in input with the parameters needed by the Python script. Okay, done, deploy, and now I will click here to send the execution of the function inside the Python code with these parameters. I click and I get the results. Let's see if okay, we have a minimum of 50 kilograms of waste collected from this waste container. The mean value is 86 kilos and the max is 180. So now we saw that to conclude this workshop, I will test if because we also implemented the error catching. If I modify something here, for example, I will put here another 0. Done, deploy. I will inject. This is for R. What do we have? We have an error, cannot open connection, and so you can debug this and find that you have let's open this and let's check it. So copy, open, paste, invalid to time parameter expected in this format. So in this way, if you formulate well the, let's see, invalid to time, you go to the to time parameter. Okay, I put invalid date. Perfect. So this concludes our workshop. Thank you for your attention and ok, grazie, arrivederci.